In this video, we are going to take a look at variables. What are variables when learning about programming? Let's take a look. From our basic schools, we've learned about variables, but how did we use them? Let's take a look at this real-world example. If we are given a question, Solomon spent 180 Ghana cedis to buy 3 hockey sticks. If each hockey stick had the same price, or if all the hockey sticks had the same price, don't mind the grammar, we are learning programming. How much did one cost? All right, now the solution to this particular problem is usually solved this way. We get a variable, or we get a symbol, we get a container, and then we represent that container at the price of 1 hockey stick. By knowing the price of 1 hockey stick, if we multiply it by the number of hockey sticks bought by Solomon, then we will get the value of 1 hockey stick. Okay, I mean the price. So think of that container as the X. Okay, this is mathematics. I am not here to teach mathematics, but I'm trying to borrow a concept from here. I think we're basically calling them variables. We get an empty container, use it to represent what we are trying to find, and then after we are done, that missing item becomes what we were looking for. All right, so we proceed. So that concept is applied in programming. Now, a variable is a name given to a particular memory location. So as we know, when a computer starts running, whether it takes an input from the user or it picks the data from a hard disk somewhere, the data is brought into memory. When I say memory, computer has permanent storage and a temporary storage. It keeps what you are currently working on inside the memory, which we all call the RAM. After it is done with all the stuff you are running, then it will discard the data. But until then, while the program is running, your data is kept in the RAM so that there will be an interaction between the processor and then the RAM, okay, for fast execution. So there is a part of your memory, that's your RAM, that keeps the data you are working with while you start using a program. Okay, so that particular place is what we term as a variable. Just like this question, the X over here is the variable in this question. Okay, all right. How are variables used? Well, I think I've spoken about this. When a program is running, the data values, the entries from your keyboard, the data from files on your disks are kept in memory while your program is still running. Okay, so that's how they are used. Yeah, they are kept in memory in containers that are referred to as variables. All right, do variables change? Huh. Let's see. Well, according to what I have here, a variable can be constant or variable. Well, no pun intended. The whole point is that we can have data kept in memory that actually change, right? So it's not a variable that can be variable. What I meant to mean was the data inside the variable. As I said, a variable can be pictured as a container in memory. So the data that you keep in the variable can be static, it doesn't change. I mean, can be constant or it can change. So that's what I mean by the variable over here. If the data is variable, then they are changed by the program or they are changed by the user, okay, based on the interaction that they have. Let's think of a variable as a box like this. We can assign values to the box and then from there we close it, okay? So in the computer's memory, there are a lot of boxes there, okay, and the boxes there too, we are supposed to give them names. The moment we give them names, then we can know that, okay, this is the box that is keeping the name of maybe the client, the age of the girl, the title of the letter, those kind of things that we interact with. Okay, so as you can see, we have one box called change me, and then the box is having an old value, but we are able to keep a new value inside the box. We'll talk about assignments in due time. All right, so this particular write-up, I've spoken about it, so I'm going to proceed. What are constants? Well, constants are data values that are not expected to change at all. Okay, they are just variables that keep data that do not change. Well, let's talk about this. I think the title is Forms of Data. We have several forms of data, so I'm going to talk about them one after the other. We have data that is in the form of a text, okay? And with text, I mean a series of characters. But characters, do I need to explain? A jumbled stream of, is it letters or symbols? Well, the whole thing is we have data that either comes singly, okay? The character is an example, but we'll get there soon. So I brought all of them here so that I can make a distinction. We have textual data, data that we type, okay, and then they are in a stream of characters. So over here, we have data. One is stored as Sandra, okay. Now with the Sandra, we have the SAN, so it's a stream of characters, right? Then we have London too. So these streams of characters are usually put in quotation marks and they are referred to as strings. So in memory, we can say we want a space reserved to keep the name of someone or the name of a client, the name of a city, somebody's hometown. Okay, so that particular space we want will be to store a string. All right, and then we have another type of data that is called a Boolean data. Okay, and with a Boolean data, it's the values they can store are the values referred to as Boolean are true or the false value. Okay, you have eaten this morning. You will say, yes, I've eaten. So it is true that you have eaten this morning. You are hungry, true or false? You choose you are hungry, right? So those are what we refer to as Boolean, okay? So the data type called Boolean has to do with values which are either true or false. Let's talk about the next data type or the next type of data. We have data being in the numeric form, okay? Any type of data coming in the form of numbers. Could be a real number, this decimal numbers, integers, and all those things. But take note, if these numbers come in quotes, they are not numbers, they are strings. So these numbers over here came like that without the quotation marks. Hence, they are numbers. But if they came in quotes, they are strings and then they are not numbers. Take note, the quotes over here are double quotes and hence we call them as strings. Over here, I'm using the single quotes to represent character data, which I mean data that comes singly. Okay, so there are characters, I mean letters and those symbols, they appear on their own. Those are character data. Okay. To use a variable, we need to declare the variable. Now we talked about a variable being a space inside a computer's memory. There's a large chunk of space inside a computer's memory. So to use any part of the memory, you need to declare a variable. To declare a variable, you need to know the type of variable you want to declare. As I spoke about, we have different forms of data. So to use a part of computer's memory, you need to say, I'm keeping a string in there. I'm keeping a Boolean data. I'm keeping a character data, or I'm keeping a number data. There are other forms of data, but this is the abridged version for us to get an overview of the forms of data that we have. So to declare a variable, you need to say, I'm keeping this particular item inside. So we say, I need a data type. I need a space of this kind of data. And then you say, I will call this space this name. From this slide, we remember we saw a variable with the name change me, but it saves strings. So we saw quotes around the values, right? All right, let's come back. So we need to know the type of data we are saving. So we need the data type, which is what we learned about over here. And then we need the name. Now, these are examples of variable declarations. As you can see on the screen, the first example has number as the type of data we are storing. And then the name for that container is age. So in this situation, someone reserved a space in the computer's memory to keep somebody's age, right? And then the age is going to be of the type number. That is why we have leave a space in the computer's memory for me. I will keep someone's age there. The age that is going to come in the form of a number. Let's take a second example. We have is married. Is married counts more or less like a question for. And is checking whether a particular person is married. So this is a variable that's in the computer's memory, and it stores either a true or a false data. Okay. We have the next one, which is a character. Most times when filling forms, we are supposed to take either the M or the F. So if you write a program and then you want input from a user, you can decide to cause the user to enter an F or an M depending on their sex. So with this character data, we have sex, and sex is taking just a character, which is either an M or an F. The next example stores the name of a client. Okay, and in the computer's memory, we will reserve the space and say we will keep a string data in there. So that's basically about declaring variables. Do we have a particular way of defining a variable or writing variable names? I wrote some of them here, but let's see if there is any rule that governs naming of variables. To name a variable, you are supposed to start with either an underscore or an English alphabetical letter. You are not supposed to begin with a number. You must declare variables that do not contain spaces in their names. You are not supposed to use any special character. So a space is a special character. You can't use a question mark in your variable name. You can't use a full stop in your variable name and other symbols. So let's take a look at a few examples of variable names that are valid. We have underscore color code. We have an underscore date. We have date of birth. As you can see, the first one starts with an underscore, and then the rest can follow, right? And then the second one starts with an underscore, then the rest also follow. So basically, these are examples of valid variable names. Okay. In the next session, we are going to take a look at another interesting part. We are going to continue taking a look at the control structures. And the first one we are going to take a look at is the sequence control structure. Stay tuned and then do subscribe to our YouTube channel and follow us on all our social media pages.